in this video. Hello everybody and welcome to my 19th video on the channel. Oh my god, we are so close to the first 20 videos and it is genuinely crazy. And one more big favor before we go into our answers to our previous questions. Please make sure to like and subscribe and also turn on that notification bell so you never miss another amazing video. Without further ado, let's go on to our answers to our previous question. For our first question, we have 6 times the logarithm base 9 of 3. For our second question, we have logarithm base 6 of 4 squared. And for our third question, we have the natural logarithm of 17 divided by the natural logarithm of 5. Let's go on to the lesson. Today's lesson is about graphing exponential and logarithmic functions. On the left, you see that the value of e is around 2.7. It's really around 2.781, blah, 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 blah. But you can just say it's 2.7 or 2.8 if you want to be more specific. Sorry. But we'll just say 2.78 just to be a little more accurate. So, you see, e to the x kind of looks like this. At negative infinity for x, y becomes equal to 0. And what you should know is there's something called asymptotes. So either they can be vertical or horizontal. If it's horizontal, as x approaches negative infinity, or as x approaches infinity, y approaches a certain value. And for vertical asymptotes, it's the exact opposite. As y approaches infinity or negative infinity, x approaches a certain value. As you can see on the right, we have natural logarithm of x. This graph actually looks more like this, as shown on the right, and it has a vertical asymptote at y is equal to negative infinity, and x is equal to 0. Y is equal to negative infinity, and x is equal to 0. So like 0, comma, negative infinity. This is probably what you would see in a regular natural logarithm graph. That's not like so we're just gonna have like one unit would be like 17, and then one unit would be 0.1. That would be way different, but I think you get the point. Let's go on to the example. For today, we only have 2 examples, and they're very simple. The first example is e to the x. Let me draw the coordinate plane and get back to you. Here's the coordinate plane, and we're going to start by graphing e to the x. If we substitute x is equal to 0, we're going to get e to the 0 is equal to 1 by property of powers. A to the 0 is equal to 1 as long as a is not equal to 0. You should know this from pre-algebra, but in case you didn't, there you know. There you go. Sorry. So, if we have e to the power of 1, we get 2.78 something. So, it would be around closer to 3, but not just there. E squared is like 2.78 to the power of 2, which is going to go pretty much higher than the graph, and there it goes. But for e to the power of negative 1, that's 1 divided by 2.7. So we would have something like over here, and negative 2, it would get really small, so we could have the graph be something like this, where of course at negative infinity is equal to x, it becomes 0. For our second equation, we have y is equal to ln x. Oh yeah, I should definitely write y here. But in case you didn't know, if we're graphing something, we will definitely just be in terms of y and x. So, natural logarithm of x, we need to graph this. What do? First, we start with the coordinate plane. Alright, so what we have here is the coordinate plane. So what we gotta do is very simple. We just graph the natural logarithm of x. So if we start with the natural logarithm of 0, that would be negative infinity. So we'll get to that later. But if we have the natural logarithm of 1, that's equal to 0. And let's just go straight to the natural logarithm of e, because it would be much easier to just have natural logarithm of e is equal to 1 than try and compute whatever the 2 is. So natural logarithm of e would be over here, and so on. If we have natural logarithm of e squared, which is around 8, not exactly, a little higher than 8, so we would have 2 over here, and the graph would look something like this. And as for as for the lower values from 1 to 0, by the way, natural logarithm can exist in values lower than 0, what you gotta do is really simple. If we have 0, it would just be negative infinity. So all we have to do is we just have to draw a line that extends all the way down here. And those are our 2 examples. Alright, what we have for today is our 2 practice problems. We have number 1, 2 times e to the x, and number 2, natural logarithm of x divided by 2. Make sure that we're actually going to be graphing these 2 functions. And if you have any questions, please make sure to say them in the comments, and it would be greatly appreciated and it would help grow the channel. See you in the next one. Bye-bye.